Hi friends. So today we are going to discuss few in-text questions from the chapter solutions. Okay. So let's move to the question. The first question here is calculate the mass percentage of benzene and CCl4 if 22 gram of benzene is dissolved in 120 gram of carbon tetrachloride. So this is the mass of benzene and here is the mass of CCl4. Okay. So we have an equation for calculating mass percentage, that is mass by mass percentage is equal to mass of the substance divided by mass of the solution into 100. Okay. For example, if you want to calculate the mass percentage of benzene, you can write it as mass of benzene divided by total mass, that is 22 plus 122 into 100. So which will get you 15.28 percentage. So if this is the percentage, mass percentage of benzene, we can easily find the mass percentage of CCl4 by subtracting this value from 100. Okay, so that you can get. So now let's move to the next question. Here the question is calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride. Okay. So it means mass percentage of solution is 30%. That means out of 100 gram of the solution, we can certainly say that there is 30 gram of benzene and the rest of the mass would be 70 gram, that is the CCl4. Okay. So from this mass data, you can find the number of moles of each. Let's say number of moles of benzene would be 30. Mass of benzene divided by molecular mass of benzene, that is 78. And the number of moles of CCl4, that is mass of CCl4 divided by molecular mass of CCl4, that is 152. So from this data, you can get the mole fraction of each. Let's say we have to find the mole fraction of benzene. In that case, you have to divide the number of moles of benzene by total number of moles. Okay. So which will be 30 by 78 over 70 plus 152 plus 30 by 78, and this is approximately 0.45. Okay, so this is the mole fraction of benzene. And in case you want to calculate the mole fraction of CCl4, you just have to subtract this 0.45 from 1. That will get you the value of mole fraction of CCl4. So let's move to the next question. Here the question is calculate the molarity of each of the following solution. A, 30 gram of this given compound in 4.3 liter of solution. Okay, we know that molarity, there is an equation, that is number of moles of solute by volume of solution in liter. Here there is no number of moles directly given, so we have to change this equation into mass of solute divided by molecular mass of solute into volume in liter. Okay. This particular term WB by MB will give you the MB, number of moles of solute. So after substituting 30, the mass of solute divided by molecular mass of this particular solute, which is 291 into 4.3, which is the volume of the solution. So after all the calculation, you will get the molarity as 0.022. Okay, 0.022 approximately. So this is the answer of first question, and there is one more subpart. That is the question number B. 30 ml of 0.5 molar H2SO4 solution is diluted to 500 ml. So in that case, it is dilution. So you can easily use the dilution equation, that is M1 V1 equal to M2 V2. Here the M1 is the initial molarity and V1 is the initial volume, N2 is the final molarity and V2 is the final volume. Okay, from the data you can easily substitute the values as 0.5 into 30 equal to M2, that is our final volume, final molarity, into 500 ml. So after calculations you will get the M2 as 0.03 molar. Okay, easy, right? Now let's move to the next question, that is 1.4. Calculate the mass of urea required in making 2.5 kilogram of 0.2 molar. This is the molality of the solution. So we know that molarity is given by solute into 1000 divided by MB into WA. So this WB here is the mass of solute, and this is again molecular mass of solute, and this is the mass of solvent. So the thing we have to calculate here is mass of solute, right? Okay, and also one more thing is absent here, we don't know the mass of solvent, right? So in order to get the mass of solvent, you can just simply write as mass of solution is equal to mass of solute plus mass of solvent. So from the mass of solvent equal to mass of solution minus mass of solute, right? So after substituting all this, we can get another equation, molality equal to WB into 1000 divided by MB into W solution minus WB. Okay. Now in this equation there is only one unknown thing, that is our WB, which is the mass of solute, and that is in this case it is the mass of urea. Okay. So now let's substitute the values given. The molarity is 0.25 and the mass of solute we don't know that, into 1000. Okay, divided by molecular mass of solute, that is here the molecular solute is urea, so the molecular mass will be 60 only, and mass of solution, that is 2500 gram. See the value, the mass of solute given in the question is in kilogram, but the equation I am using is for when the masses are given in gram only, so that is why I am converting the mass into 2500. So from 2500 you have to subtract the value of WB. So after solving the WB, you can get the value of WB as 36.9 gram. Okay, easy. So now let's move to the final question. The question is, calculate the molarity and mole fraction of Ki if the density of 10% mass by mass aqueous solution of Ki is 1.202 gram per ml. So here in the question they have given the mass percentage of Ki and the density of the solution, right? So from the given data, if we are doing this question by conventional method, it will take too much of time. So let's do it so quickly by simple equations. Okay, you have to remember this equation. Okay, so first of all, I am starting with the molarity. Molarity equal to 10 dy by molecular mass. Okay, here d means the density of solution, which is given in your question. Y is mass percentage of solution, and Mb is the molecular mass of solute. Okay, after substituting the values, you will be getting 10 into 1.202 into 20 divided by molecular mass of solute. Since the solute is Ki is your solute, so the molecular mass of Ki is 166. So after substituting all these values, you will getting the molarity as 1.45. Simple, right? Okay, so we have to remember this equation, this particular equation. There is another equation for molality, which is molality equal to 1000 into molarity divided by 1000 into density minus molarity into molecular mass of solute. Okay, so on substituting values, 1000 into 1.45 divided by 1000 into 1.202 minus 1.45 into molecular mass of solute, that is 166, and you will get the answer like 1.45 molar. That's too easy, right? And the final equation, we have to calculate the mole fraction, right? So in order to find the mole fraction, now we have the molality, and there is a relation between molality and mole fraction, that is molality equal to 1000 into mole fraction of solute divided by 1 minus chi b into molecular mass of solvents. See here the molecular mass of solvent you have to use. So on substituting 1000 into chi b, which we don't know, okay, divided by 1 minus chi b into molecular mass of solvent, that is 18, will become molarity, and which is 1.5. And after solving, you will get the chi b as 0.26 approximately. That's it. Okay. Thank you for watching.